Okay, so 1-4B, part 2. Our notes, finding equation of inverses. Remember, these are the 3 steps that we follow. To find the equation of the inverse, step 1, we're going to switch x and y. Agreed? Step 2, we're going to solve for y using inverse operations. So we're doing PEMDAS backwards, right? That's an arrow, go with it. And then we're going to write our final equation using inverse notation. That's using inverse notation. Capiche? All right. So here we have y equals 2x squared minus 6. So previously we were working with linears. Now we're working with a quadratic, okay? So we're working with the quadratic. Step 1 is to switch my x and my y, okay? So switching my x and y leaves me with x equals 2y squared minus 6. Okay. Step 2 is to start doing whatever I need to do to get y by itself. So what's the first thing I need to do? I'm going to add 6. What I do on one side, I do to the other. These are not like terms, so they just become neighbors. All right. What else do I need to do to get y by itself? Divide by 2. And when we divide and multiply, it affects all terms. So that leaves me with x divided by 2 plus 3 equals y squared. All right. Is y by itself? No. How do I get rid of a square? Square root. And what I do to one side, I do to the other side. Okay. So now, step 3, y is by itself. So my inverse equals the square root of x divided by 2 plus 3. When you take the inverse with the square root of something, it produces a positive and a negative solution. Okay. Now, this is just a relation. And we're going to talk about more today why it's a relation. But this is a relation, not a function. Okay. In order for it to be just a function, we couldn't have that plus or minus, because that plus or minus is going to create a shape like this. And does this pass the vertical line test? No. So in order for it to be a function, it would have to just be the positive of it. Okay. But this is the inverse relation. Are we comfortable with that? Yeah. But because if I was to graph this, it would create a sideways view. I would have to have only the positive, not the negative, and the positive as possible as a function. Okay. The other thing here is, I'm going to get my blue pen, restrictions. On your notes last week, I want to say 1-3B notes. We talked about restrictions. So on your 1-3B notes, it was restrictions. And with the square root, what is a restriction? It cannot be what? What kind of number? It can be a negative number underneath the square root, right? So if I can't have a negative underneath the square root, then there's a restriction for this answer, for my function to be a function. And so last week, you should have did this or felt familiar where you had to figure out what's the restriction. X has to be greater than or equal to something, right? 0. And so what would X have to be in order for this to be true? Well, what would you do? Well, what I need to do to find X? What are the 2 steps that it takes to find X here? Subtract 3 and then do what? And multiply by 2. So when I subtract 3, and then I'm going to multiply by 2. Does that make sense? So my restriction would have to be -6. So in order for this, again, if it's just asking for the relation, we can stop here, right? Does that make sense? Relation, done, bam, boom, cool. If it's asking for the function, then the function would be the positive and it has a restriction x has to be greater than or equal to -6. So this is a little extra. This is just the minimum. Can you find the relation? Yes. What's the relation? Awesome. Is it a function? No. Can you make it a function? Sure. Okay. So that's why last week it was important for you to do the 1-3B notes on understanding restrictions. And there was 2 types of functions with restrictions. You had square roots and you had rationals. All right. So we have the equation for the inverse of each of the following relations. Sorry, number 5. We're doing a square root. So we have the square root of x squared plus 5, and we want to find its inverse. Does the step 1 change? No. So step 1 is still switching x and y. So we have x equals the square root of y squared plus 5. What are the steps it's going to take for me to get y by itself? It's the inverse of square rooting something. To square it. So I'm going to take the square of the square root, and what I do to one side, I do to the other. So this becomes x squared. So this cancels out, and I'm left with x squared equals y squared plus 5. Fun fact, this is the equation of a circle. Yeah, probably don't remember that from geometry, but this is the equation of a circle at the origin. It's all right. It's cool. It's cool. All right. So what else did you do to get y by itself? I'm gonna do what? I'm gonna subtract the 5. So I have x squared minus 5 equals y squared. Is y by itself yet? No. What else do I need to do? Square root. And now it's by itself. So my inverse equals, I didn't mean to write equal in front of the F. My bad. Equals plus or minus, because when you take the square root of something, what happens? Creates a plus or minus 5. Okay. If it was by itself, so that minus 5. Okay, so again, this is a relation. Is it a function? No. What prevents it from being this function is that plus or minus guy, right? All right. Questions, comments? Yes.
Oh, and like a test, do you have to make it related, a function?
Do you have to? I think you may have to for the square, like the one that we went full on. Yes, be able to identify it. But it's multiple choice, so hopefully that would narrow it down. I didn't make the test, but I know that it's multiple choice. So, all right, 6. Our test is Thursday. 6. So now we have a rational. So we have a rational. Does anyone remember what we talked about for the inverse of a rational function in our parent function notes? Probably not. Okay. Well, I guess we'll just figure out what we talked about. All right. So step 1 is to switch your x and your y. So we have x equals -5 divided by y. Before you can do anything, you have to get y out of the denominator. It's something in the denominator, that means it's being divided. What's the opposite of being divided? Multiply. So we have to multiply both sides by y. And we end up with y times x equals -5. To get y by itself, we're going to have to divide x. OMG. What happened? What happened? It's literally the same thing with a rational function at the origin. It is the inverse of itself. It's its own inverse. And just to make this a function, x cannot equal 0. Because we can't have what in the denominators? 0. But in our parent function notes, we wrote that rational functions are the inverse of themselves. All right, that concludes 1-4B.